Hello everyone. In this opportunity, I am going to record another video for you. And okay, first of all, let me show you once again this. This is the syllabus. So, wait me a moment. Sorry. I already gave you two videos about data representation. So if you notice, I have to record for you around 10 or maybe 11 videos. Why? Because in this one, I already record two videos, and today I'm recording this video for you about data transmission. Okay, so let's start. Data transmission, Hmm. data packets. So before I start reading the slides, Hmm. sorry, let me start explaining you this. Let's suppose that you are going to send a pair of shoes. Let's suppose this is a pair of shoes. Okay? So you are going to send them to a relative, for example. So you take those shoes and you take them, for example, to TCC, Servientrega, or another delivery company, and they put those shoes inside a box. Okay? Listo. Okay, okay. This box with the shoes inside are called packet. Okay? So this is what you are sending across. In this moment, you are sending those shoes to a relative. Okay? Now, why I'm talking about this? Because talking about computer systems, let's suppose that this is one computer and this computer is connected to another device that is called router, and we have, for example, another device here, another computer. Okay, let's suppose that this is a desktop computer and the first one that I draw is a laptop. So you are going to send, for example, an image. Okay, you are going to send an image, a picture of you. Okay, so when you start sending that picture from this computer to this one, the computer creates a packet, and that packet is sent across the network from the computer number one in this case to the computer number two. Okay, so now let's continue with the slides. So, why is data broken into packets? So, when data is sent across the network, like the internet, or let's suppose during the school, you have one file in your computer and you are going to send it to another classmate in the school. So, you are using the school network. Okay, so if you are going to send something across the network, sending in just one piece is too large. Okay, so that is the reason that the computer breaks the information that you are sending into a smaller pieces. Okay, so those smaller pieces are called packets. Okay, so why use packets? So let's back here. Let's suppose that there is another computer here, and this another computer is sending another information across the network from this computer. This is the computer number three, and is going to send it to the computer number one. Okay. So if there are many, many computers at the same time sending information, so the reason that we use packages or the computer breaks down the small packet into a small, the biggest package. is breaking down into a small package. This is just for avoiding network congestions. So what is that? Think about this. Let's suppose, let me here. Let's suppose that this is your home, okay? And you take the route to go to the school. So let's suppose that here we have the school, okay? So this bus is going to travel from your home to the school. So you notice that there are many people travel maybe to the same place or another place that is closer to the school. So the traffic is heavy. That means let me tin. That means congestion. Okay, so if you send small pieces, you are avoiding heavy traffic. Okay. Okay, why do we use package? To make transmission faster and more efficient. Why faster? Is because it's easier to send small pieces than a huge package. Okay. Now to allow different package to take different routes and still arrive this destination. I'm going to get back here. And let's suppose that we have those roads going to the school in this road path, for example. And let's suppose that here we have another path to go to the same destination. And let's suppose that we have another path here to go to the same destination. So if these routes, for example, route number 1, 2, 3, and 4. Let's suppose that the route number 4 now is going to take the red path, and the route number 1, for example, takes the blue route or path. Okay, so that means that the route number 2 in this case and the route number 4, they are going to have less congestions. So that means that they are going to arrive faster. The same for the route number 1 and the same for the route number 4. Okay. And to make error detection and correction easier. So that is another topic that we are going to talk in this video, but not in this moment. Okay. So how does it work? Data, like an email, video, or web pages, is divided into packages. Each packet is sent separately across the network. At the destination, the package are reassembled into the original data. If a package get lost, only that package needs to be resent, not the whole file. So let me explain you here. Just doing drawings. Okie dokie. So let's suppose that we have this computer, the internet, for example. Let's suppose this is a cloud, and here we have another computer. So you are going to send an email. Okay, so let's suppose that this is the email. This email, sorry, is going to be broken. Let's suppose that it's going to be broken in 4 pieces. Okay, so let's suppose that the packet number 1 travels. Let's suppose that you get in London, and from London gets to the destination. The packet number two is going to travel around through New York. Sorry, New York. Then the second package arrives to the destination. Now let's suppose that the package number three is going to travel, for example, through Japan. Then the package arrives to the destination. And the package number four, okay, let's suppose four here, is going to travel through Australia. Then the package arrives to the destination. Now, in the destination, your package is going to be reassembled once again. But what happened if the package number three is lost? Mhm. No, no. Let's suppose that the package number three is lost. So this computer, this computer is going to resend just the package number three. Okay? Okie dokie. Let's continue with the other one. So, data package has three key parts. So, the package has the header, the payload, and the trailer. Okay? So, what is this? Let me come here once again. So, that package that I show you in this drawing, that email, so first is going to be broken in four pieces. And in addition, is going to go with something that is called header. And in addition, is going to go with another part that is called trailer. So, what is this? In the header, you have the destination address, you have your source address. What is this? The destination that you are going to send the package. This is the address of is your address. Okay. For example, let's suppose that you are going to send something from the school to your home. So the source address is going to be the school address, and the destination address is going to be your home. Okay. So what else the header has? The package number. Okay. So that means that inside the header, you are going to say that you are sending four packets, those four packets, just for this example. Okay. Now, what is the payload? The payload is the whole package. Okay. The part one, the part two, the part three, and the part four. This is the payload. Okay. So I have the drawing here. This is the payload. The part one, the part two, the part three, and the part four in this example. And what is the trailer? The trailer includes the way that the destination is going to verify if the information travels correctly. That means that you are going to use the trailer for checking error transmissions. Okay? Okay, okay. Let's continue here. Okay, this is just a visual example about how something is sent from a computer to another computer. So here we have the example. The header has Two, what is two? Destination. And this is the IP address of the computer that is going to receive the information, the original source. So this is the IP from the information is going to go out. Okay, and the packages. Okay, now the payload is the information indeed. Okay, the information says, hello, this is part three of the message. This is all the information that you are sending from one computer to another computer. This part. Okay, and the trailer has something in this case that is called checksum. That is the way that we are going to check for errors. Okay, so why the header is so important? Because without a header, the package doesn't know where itself has to go. The receiving computer wouldn't know how to put the package back in the correct order. What that means, for example, here we break down the package into four pieces: the part number one, the part number two, the part number three, and the part number four. Without this information in the header, the destination is not going to be able to reassemble this information. That means that, let me suppose that we are going to reassemble this email in this way: 3142. So the information is not going to be as the original one. Okay. And error handling would be difficult. So, what if we have an error sending this package? I'm going to use another one. Let's suppose that we have an error for sending this package. So, if there is not a verification of errors or a error detection, so the information that you receive, you don't know if that information is the correct one. And the sender thinks that you receive the correct information. Okay, so that is the reason that the header is so important in this part. Okay, now packet switching. What is this? Packet switching is a method of using or sending the information across the network, like the internet, but splitting the data into smaller units called package. So it's the same that I already explained, but let me draw in once again here, and let me show you this part. Once again, let's suppose that you are sending an email. Okay, so you break down this email into four small pieces. When you break down this, that is, sorry, that is called package switching. Okay, so packet switching. This is what this concept means. Okay, now, how does packet switching work? So, step by step, data is broken into small pieces. Large files, video, emails, web pages are split into small pieces. Each packet takes its own route. What that means? So, let's suppose that this is the computer source. The information is going to go out, and this one is the computer destination computer. So that means that we are going to send something from this computer to this computer. So the part one may take this route. The part two may is going to take this route. The part three is going to come in this way. And let's suppose that the part four is going to do something like this. Okay. So The packets do not need to follow the same path. They may go through different routers and networks based on traffic and availability. And this makes the network most flexible and efficient. Okay? So imagine that, let's talk about real life. The only way, if you live in Bogota and you need to go to the school, there is just one way to get there, and is for the Autopista Norte. And that is the reason for the heavy traffic. Imagine that for arriving to the school, we have four ways. So the transportation from your home to the school is going to be easier. Okay, so that is the reason that the package always take different paths. Okay, so I didn't explain this. So let's suppose that, let me show you my drawings. That here is your home, and inside your home you have something that is called router. Okay, and you are connected like this. You are connected to the router. Okay, and the router sends the information across the internet or the cloud. Okay, so the router is the one that is going to check where the package needs to go. So that is the first thing that the router is going to do. Is going to check where the package is going to go. For example, let's suppose that here we have the destination, another computer in another part of the world. So here we have our message. And remember that here we have the header. And remember that in the header we have the destination address. Okay, so the router is the person in Servientrega that is going to read your box and is going to say, okay, these shoes are going to go to Manizales. Okay, now the router select the best available paths. So, for example, you're going to send those shows to Manizales. Okay, so it says, okay, we can send this using a mailman that is going to go in a motorcycle. It's going to take more than 8 hours. Okay, you can send it using um, transportation by earth. So that means that you are going to take, let's suppose, 7 hours. And you can send it by plane. And by plane, you are going to take 30 minutes. So the router is going to select airplane. Okay. So the routers consider factors like network traffic, broken connections, and speed of different routes. Okay. Let me check this here. Okay. Now the package arrive at the destination. So because they need take different parts, package may arrive out of order. What that means? So let's suppose that we send the package one, two, three, and four in this order. And maybe all the information arrives in this order. First, the part number three, then the part number one, then the part number two, then the part number four. Okay? Now, After we receive the packages, all the packages, now this computer needs to reassemble the information in the way that you have the information as the original one. Okay? Okie dokie. So that is all in this slide. Okay, what if one packet is missing or if the package is corrupt? So let's suppose something like this. I'm going to delete everything once again, and we are going to do something like this. This is the computer that is going to send information, and this is the computer that is going to receive the information. You are sending this email broken into these four small pieces. Okay, so the information is sent, and when this computer receives the information, receives something like this: three, one, two, and this part. So in the header, you have the information that you are sending for packets. So this computer is going to say, okay, I have the part one, I have the part two, I have the part three, and this part I can read it. So can you please resend the part that is missing? You said, or you have in your header that you are sending four parts, and as I just received three, or I received four, but one of them is not readable. So that is corrupt. So please, I got the part one, the part two, and the part three. Can you send the miss one or the missing one? So this computer is going to resend the part number four. Okay? Okie dokie. So why is packet switching so important? Is efficient use of network resources. Is reliable even if part of the network fails. What that means? Let's suppose that we have something like this. Let's suppose something like this. This is your home. This is the school, and you're getting this path to go to the school. But let's suppose that something happened here. The path is broken, so you cannot go to the school using this path. So what happens that you are going to take another way. Let's suppose that from here, you're going to be able to connect to another path, then you arrive to the school. Okay? That is one of the reasons why the package switching is so important. Now, helps manage high traffic without without slowing down the whole system. The same that I do here. The same that I did here. Okay, so I'm going to let me explain this part once again. So this is your home, this is the school. You are taking this path, but something happens here and you cannot continue. But here we have another, sorry, we have another path. So you are going to take a deviation from here to here and you continue your way to the school. Okay, so makes that the you are not going to affect the system. Why? Because you are using different roads to achieve or to get to the school. Okay, okay, dokie, and reduces the change of total data loss. What that means? That you are not going to lose all the information. Maybe you can lose one part of the information. And if you lose one part of the information, you resend it. Okay? Okie dokie. So let's continue here. Okay. Now, we have different ways to send the information. Okay? So this is what I'm going to start explaining right now. So types of data transmission. We have serial transmission. How does it work? So let's suppose that you have your computer here and you are going to send information to that computer. So that means that if you use serial transmission, that means that you are going to send bit by bit. What that means? That here you are going to send the first information here. So 1 bit. Then you are going to send another bit. Then you are going to send another bit. Then you are going to send another bit. That is serial transmission. Okay. Um, that means that information that you are sending is going to take longer than using another transmission methods. Okay. So that means that it's going to be slower. Okay. So examples of serial transmission, your USB and Ethernet cables. Advantages is cheaper. You don't need a lot of wires to send information. Less chance of interference. That means that is, for example, you are in a phone call and you are talking with someone, with your bestie, and let's suppose that you are talking about anything, and you start listening another conversation that is not yours. That is interference. So using serial transmission is that means that you are not going to have interference, but the chance of having interference is less. Okay, and the serial transmission is good for long distance. Okay, now we have parallel transmission. Okay, so what is this? In parallel transmission, you are not sending the information bit by bit. You're going to be able for sending more than 1 bits at time. I'm going to give you just an example. Let's suppose that here you are sending 3 bits. That is parallel transmission. Okay, is faster than serial. Okay, but the real way that you are using the parallel transmission is inside the computer. So that means that if you are going to send information from one computer to another computer, that means that you are using serial transmission. But let me give you an example. Let's suppose that this is the CPU. The CPU or the processor needs some information that is located in the ROM. So you are going to use something that is called bus, data bus. So in this data bus is going to travel more than 1 bit per time. So that is the reason. I was drawing and I didn't show you. Okay, this is that I was trying to show you. If you are sending information from one computer to another, it doesn't matter that you are using a router or to send in the same network, or you are using the internet for sending the information. You are sending the information bit by bit. This is serial transmission. Now, parallel transmission is just for the information that move across the computer, inside the computer. That is the place that parallel transmission works. And I was trying to show you that let's suppose that here we have the CPU, and let's suppose that here we have the RAM memory, and we have something that is called data bus. Okay? When the CPU takes information from the RAM memory, in the data bus, let's suppose that you have something like this. And one, two, three. Let's suppose that this is a highway. Okay. So that means that for each single port, you can send bits. For example, in this one, let's suppose that you are sending 3 bits per time. Okay. So this is the application of parallel transmission. Okay. And advantages is faster over short distance. Disadvantages is more expensive. You need more wires. Okay? And maybe you are going to have problems in timing. What that means? That means I'm going to give you an example. Here, if you are sending information using parallel transmission to long distance, so let's suppose that, for example, let's suppose that in this computer you are sending information to this another computer, okay? And remember that this is for long distance. So let's suppose that you have a so long wired. Oh man. Okay. So you are going to use, let's suppose that you are going to send the same information but using parallels. So let's suppose that you're sending in this way. So using parallels, you see for sending the information is going to expend more time for sending the information. Okay, let's suppose that you are expecting that the information is going to take 30 minutes. And when you send information using parallel transmission, let's suppose that it takes 40 minutes, more than you expect. Okay, so that is a one disadvantage that we have in parallel transmission. Now, this is the way that you use different types of transmission. So you have serial and parallel. Now, we have something that is called the direction of the information. Okay, so this is when we are going to start talking about this concept, simplex. That means that the information is going in just one way. One way. Then we have duplex. Duplex means that you are going to send the information in both ways, but you cannot send them at the same time. That means that, for example, if one package is going from the left to the right, in the same time, you cannot send something from the right to the left. So you need that the package that is sent from left to right arrives, then you can send from right to left. That is duplex. And the other one that we have is full duplex. That means that you are going to be able to send and receive information at the same time. Okay, let's check here. Now, for the IGCSE exam, it's important not only to know the types of data transmission, but also when and why each one is used. So let's talk about this. Serial transmission. When to use it? When you are going to send information across long distance. Okay, and when obviously the cost is significant. So if you need to send information and you need to reduce cost, use serial transmission. Okay, but you need to remember that is using mm, sorry serial transmission is slower than using parallel for short distance. Okay, examples when you are using USB devices, mouse, keyboard, flash drives. Okay, okie dokie. Parallel transmission. When to use it? In short distance, and you need high speed communications. Okay, advantages is faster and you can send multiple bits at once. For example, you can send 8 bits, 16 bits, 32 bits, or more than that. Okay, disadvantages so expensive. Okay, and as I told you, you are going to have timing uses over long distances. Let me give you an example. Let's suppose that let me try to check something here. Images, concerts. Okay, so let's suppose that the scenario when band is giving the concert, you have only speakers on the scenario. Okay, that means that the people that is in the concert that is closer to the scenario is going to listen to the music faster than the people that is so far in the scenario. Okay, so let me doing it this like this. Let's suppose that this is the scenario and you are here singing. Let's suppose that this is music. And here you have the speakers. Ding, 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 and the other speaker here. So the people that is in this part is going to listen the music faster than the people that is in this part. So the time that the sound is going to get from the speaker to this part is not the same than the time that the sounds take from the speaker to this part. That is timing. Okay? So this is the disadvantage for using parallels in long distances. Okay? Example of scenarios, communication inside the computer and older printer cables. Let me show you. Mm, printer cables. So these are the printed cables of today. This is serial, but if I use here the word old printed cables, is longer. This is parallel. Okay, and this is used for short distances, and this is used for long distances. Okay, okie dokie. Let's continue. Simplex transmission. When to use it? When communication is one way only. Okay. Simplex. Okay. Half duplex transmission is when you need two-way communication, but not at the same time. Okay. And full duplex transmission is when you need a faster communication and simultaneous two-way communication is needed. Okay, obviously this is more expensive that have duplex. Okay, now I told you that the USB is one example of serial transmission. So, what is USB? Universal Serial Bus is an standard interface used to connect external devices to our computer or other electronic systems. Is one of the most common methods of data transmission and power delivery between devices. Okay, so for example, when you are connecting, let's suppose that this is our computer, and let's suppose that you are going to connect a printer not by Wi-Fi but using wire. So you are going to use a USB cord. Okay, so in here in this USB, you are sending data and you are sending power supply. In which cases you are using power supply, just connecting a pen driver, your memory USB, okay? Or for example, when you are connecting your cell phone to the computer, you are using data transmission and power supply, okay? Examples of US devices: flash drives or pen drive, keyboards, mice, that is mouse in plural, printers, external hard drives, a smartphone for charging and data. Okay. Now, how does USB transmission data? Okay. So serial, when you are going to transmit data using USB, that uses serial transmission. That means that the information is sent bit by bit at time. Okay. Is plug and play. What that means? You connect the device and the computer, the operating system recognizes the device that you are connecting. Okay. And is hot swappable. That means that USB devices can be connected and disconnected while the computer is running without causing problems. Okay. So that means that you are going to be able to connect your cell phone and disconnect your cell phone, and you are not going to have any problems. That is in Spanish is called que lo puedes desconectar en caliente. Un ejemplo, pueden haber cosas que tú desconectas así a lo brusco y se puede dañar. Mediante el USB, no. That means hot swappable, that you are going to be able to connect and disconnect, and you are not going to have nothing broken or any problem. Okay. So, basic process of USB communication. So, this by sorry, the device connection. You plug a USB device into a USB port. Device recognition. So, when you connect something to a USB, did you listen the sound that the computer um, plays? Oh man, that is device recognition. Okay, I want to try to let me try to put all the volume up, and I am going to disconnect one device. Did you listen that sound? That means that I disconnect a device. If I connect the device once again, that sound means that the device was recognized. Driver activation. So, for example, if you connect a mouse, the computer recognizes the mouse and the computer activates the driver. What is a driver? It's a small software that allows allows you to use the mouse in this case. So if necessary, a driver is installed or activated so the device works correctly. Data transmission. The device and computer begin transmitting data through the USB connection using serial communication. And as I told you, power supply. Okay, benefits of using USB interface. Okay, here we have benefits is universal standard. That means that works across almost all modern devices. Plug and play, easy to install and use. Hot swappable, I already explained you what is that. Provides power, that means power supply. Multiple devices, USB hubs allow connection of multiple devices. Do you know what is a USB hub? I am going to show you USB hub. So that means that you are going to be able to connect just using these many devices. In this case, you are going to connect one, two, three, four devices. Okay. And different speeds. So we have USB 2.0, and USB 3.0, and etc. Okay. Now, drawbacks. Drawbacks. That means disadvantages. Limited cable length. So if you are going to use a USB cable so long, so maybe you are going to have loss of information. Speed limitation is slower than some newer connections like Thunderbolt. Power limitations cannot supply enough power for all devices. And port sharing bandwidth if multiple devices are connected through the same hub. I'm going to give you an example with this. Let's suppose that if you connect, let's talk about networking. Let's suppose that you connect just one computer to the network. That means that you are going to have 10 megabits per second of sending information. But if you use a hub and you use four computers in the same hub, that means that 10 megabits per second is going to be divided by 4. So that means that each computer is going to send information with a speed of 2.5 megabits per second. So in USB is the same. Okay. Okay. Methods or error detection. So remember that I'm draw you something like this. Just you have the header, you have the payload. Let me correct the way that is writing. Payload, and you have the trailer. Okay. So here you have the information where the information needs to be sent to, the place where the information is sent from, um, the number of packages. Here are the packages, and here we have the error detection method. So it's the way that we are going to detect if in our data transmission we have any kind of mistake or error. Okay, so let me get back one here. Okay, so why error detection is necessary? When data is transmitted from one device to another, errors can occur during transmission due to issues like electrical interferences, signal degradation, noise on the transmission line, data loss or gain, and data corruption. Okay, so electrical interferences means that, let me show you here. I'm going to delete this part now. Let's suppose that you are sending this signal. And let's suppose that when you are sending this, another signal, you something like this. So this is interference. So that means that you have an error sending the transmission. Signal degradation. So let's suppose, and this is for long distance. Okay. So let's suppose that if you have one computer here to here, the strong on the information is going to be, let's suppose something like this. Okay. Let's suppose that here you got, let's talk about information 10. Okay. And if you have long distances, so let's suppose that you are sending information, and here let's suppose that you miss one part of the information. Here you miss another part of the information. So at the end, you receive just 8. Okay. Noise in transmission line. So let's suppose that you are, have you ever heard? Let's suppose that you are listening to music in your computer and you have your speakers, and try to make a phone call using your cell phone and put your cell phone closer to the speakers. You are going to listen another noise than the music that you are listening to. That is noise on the transmission line. And data loss again, obviously you are going to, let's suppose that um, you are going to miss some bits in the information that you are sending. Or data corruption, for example, you are sending a 1 and the destination receives a 0. So that is data corruption. Okay, this one, let me use this and this. Okay, we have an error detection method that is called parity check. What that means, that let's suppose that we are going to send this information 0 1 1 0 1. Okay, you need from this information a bit that is going to have the parity check. Okay, the parity. Okay, you know what I'm talking about. And you can use oath parity check or even parity check. What that means? What that means? If you are using even parity check, that means that the number of ones that you have in the package must be even. So if you notice here, we have 1, 2, 3. So here we need to put 1. Why? Because we are going to have 1, 2, 3, 4 ones, and 4 is an even number. Do you remember that? And now let's suppose that you have the same information 0 1 1 0 1, and here you have your parity bit, and you are going to use auth parity check. That means that here I am going to put a 0. Why? Because auth means that we are going to have 1, 2, 3, and 3 is an auth number. Okay, so that is about the parity check. Parity check purpose I already explained you, so I can go to another one. So checksum. Checksum is just for calculate a block of data. Okay, So all the information is added together, and that total is divided often by 256, and the remainder is the checksum. So I am going to give you one example, or the same example that we have in our slide. I am going to write here the data 34, 56, and 12. Okay, here. So this is the information that we are sending. Bit 1, bit 2, bit 3. So the next bit is going to be our checksum. So what are you going to do? You're going to have 34, 56, and 12, and you are going to add them. Okay, here we have 2, and here we have 102. So this number is going to come here. So you send the information to another computer. The other computer is going to receive the same 34, the same 56, the same 12, and the same checksum. So the destination is going to add this information. And if the result of this adding is equals to the checksum that we sent, that means that there is no error in this data transmission. If the result is different, that means that you have a loss of data. There is an error. Okay. Echo check. What echo check means? I'm going to give you an example. Let's suppose that here, let's suppose that this is a teacher. And let's suppose that this is you. Mhm. Okay. Now, the teacher is going to give any information to the student, and this student repeats the information to the teacher. For example, can you give me that pencil, please? The student is going to say, this pencil? Yes, that pencil. So it's a echo. Okay, that is echo check. That means that the computer one is going to send information to the computer two. So the information is sent. The computer two is going to say, okay, this is what you sent. If the information that the computer two sends to the computer one is the same information that the computer one sends to the computer two, there is no error. But let's suppose that the information, let me delete like this. Okay, now let's suppose that the computer one sent an information to the computer two, and the computer two sent the information that he receives, and the information is different. That means that we have an error. So the computer one sends the information once again. Okay. Okie dokie. Here we have an example. You send hello, receiver echoes back hello. You compare and confirm if it's correct. Okay. So we have the check digit. Okay. But let me try to explain you something here. Sorry, I have to stop recording because I'm sick. Okay, check digit. Check digit is an special digit add to the end of some numbers. For example, when you are going to go to the library use something that is called ESB is a ESBN is an international standard book number. So in this part here, let's go to the CCA and take one book and must have something like this one. Okay, so let me take this information. So this is some numbers that the books is going to have. The last number is the check digit, and this check digit is calculated with a specific formula. For example, I want to give you an example. Let's suppose that we have the numbers one, two, three, four. Okay, and let's suppose that here our last digit is going to be our check digit. Okay, and let's suppose that our check digit is going to be the result of adding those numbers. So 1, 2, 3, 4. So here, what do we have? We have 9, right? No, 10, sorry. 10, 10, 10, 10, 10. It's going to be the number 10. But here we're going to use just one digit. So let's suppose that this is going to be my ISBN code. 1, 2, 3, 4, 0. Okay? And what happens if someone tries to put this code? 1, 2, 3, 4, 1. So this means that here we have an error. Why? Because the check digit doesn't match. Okay, so this kind of error detection is used in libraries. Okay, so for example, the ISBN check digit simplified. So here we have this information. So the check digit is going to be calculated using a formula. Okay, so I give you an example. This was my formula. Let's suppose that my formula is that the check digit is going to be the adding of the other numbers, but that is not always the same in all the ISBN library codes. Okay, so the only thing that you need to know is that the check digit is going to be calculated using any formula, and when you try to, let's suppose that you are having a database, you have all your books in a database and you start writing this code, for example, and let's suppose that the book that is registered in the library is 6, and let's suppose that you wrote 4. So there is an error and you are going to have a message that says that that book doesn't exist. Okay, so this is about the check digit. Now, where a check digit is used in ISBN numbers, using for books to check if the number is valid. In barcodes for products that you have in, for example, in your store, and credit card numbers. So let me show you here. I already showed you the ISBN codes, barcodes. Let me see it here. Barcodes. The check digit is the last one. And credit, credit card number. Okay. As we have here, we have the same in the credit card numbers. So look at here. The credit card numbers use something that is called checksum. But this one, the last one, is the check digit. Okay. Okie dokie. Now, let's continue. Parity byte and parity block check. The parity byte is this what I already explained you. Let me delete here. No, it's not this one. So I'm going to delete this. So let's suppose that you are sending this message. 1, 2, 3, 4. Okay. And this one is our parity byte. So if you are going to use even for error detection, that means that here I'm going to put a 0. This is my parity byte, this one. Okay. But now if we're talking about a parity block, that means that we are going to have something like this. I don't remember if I guess, sorry, that you remember this exercise that I put you in class the previous year. So let's suppose that here we are sending this information 0, 0, 1, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 1. And now let's suppose that, okay, no, 1, 1, 1, 0, 0. Now let's suppose that in this block we want to use even parity check. Okay, so here we have 1, 1, 1. That means that here we are going to put 1. Why? Because we need to have even number of ones. Here we have 1, 1, 1, 1. So that means that here I'm going to put 0. Here we have 1, 1, 1, 1. So for ones, that means that here I'm going to put 0. Here we have 1, 1, 1. That means that here I'm going to use 1. And here 1, 1, 1. So that means that here I'm going to put 1. Okay. So I hope that you remember this. That is called parity block check. Okay. Obviously, if you want it, you can have something like this. And this is our parity bit. And this is going to be our parity bit. So that means that here we have 1, 1. Here going to use 1. Why? Because I am using even. Here 1, 1, 1. Here I'm going to put 1. Here we have 1, 1, 1. I am not showing you. Okay, so let me. Okay, I'm going to explain this once again, but faster. Okay, okay. This is for parity block check. So let's suppose that we are going to use even. So that means that the number of ones must be even. So here we have 1, 1, 1, 3 ones. So here I'm going to put 1. Here we have 1 and 2. So that means that here I'm going to put 0. Here we have 1, 2, 3, 4. So here I'm going to put 0. Here I have 1, 2, 3. So here I am going to put 1. Here I have 1, 2, 3. So that means that here I am going to put 1. And I have to do the same with the columns. I already did it with the rows. Now I'm going to do it with the columns. So here I have 1, 1. So 2 ones, 0. 1, 1, 1. 3 ones. So that means that here I must add another one. Here we have 1, 1, 1, 1, 0. Here we have 1, 1, 1, 1, 0. Here we have 1, 1, 0. Here we have 1, 1, 1. So here I need to put 1. Okay? So that is parity block check. Okie dokie. We're almost done in this video. Oh, this video, it's been so long. We have 1 hour and 15 minutes. Oh my goodness. Okay, this one. Automatic repeat request. ARQ. So what is that? The automatic repeat request is an error control technique that is used during a data transmission to ensure that the data is received correctly and without errors. So let me explain you this. I'm going to try to do it a little bit faster. Okie dokie. Okay, let's suppose that here we have a computer. Here we have another computer, and we are going to send information between those computers. So these computers send that information here. Ping. Okay, so this computer is going to send maybe this green arrow or maybe this blue arrow. Arrow. The colors doesn't mean nothing here. Okay, guys? But for me, the green one means that we are going to have a positive acknowledgement, and the blue means negative acknowledgement. What that means? Sender transmit the data to the receiver. The receiver checks the data for errors using techniques like checksum or parity checks. The receiver sends back one of the following. If the sender receives an ACK, it sends the next block of data. If the sender receives a NAK, it resends the data. I'm going to explain you something here. Let's suppose let's suppose that we are going to send information sending two packages. Okay? Let's suppose that this is divided in one and two. So this is going to send the number one. If this computer using a checksum or parity and there is not any error here, this computer is going to send an ACK. What it means? Positive acknowledged. That means that information has no error. Then the computer is going to send the other package. And obviously, and now let's suppose that in this moment, this computer sends the package number two, and here in the checksum or in the parity, there is an error. So this computer is going to send a neck. What that means? Negative acknowledgement. That means that there is an error in the transmission. So this computer is going to send again the second package. Okay? Until this computer receives another ACK. That means a positive acknowledged. Okay? Now, we have something here that is called timeout. Okay? So if the let me try here doing this once again. So let's suppose that this computer is going to send information to this computer. So send the information, not response. What that means? That is that this computer doesn't send an ACK or a NACK. That possibly could be that this computer is off. So this computer is going to send information again. If not, the information is going to send the information again. And let's suppose that we create an algorithm to send this information 10 times if there is no answer. So if the information was sent 10 times, so this computer is going to send, the other computer is off. So it's going to stop sending the information. It's the same when you are calling your boyfriend or your girlfriend. You make one phone call, not answer, you call it again. Not answer, you call it again. Not answer, you call it again. No, maybe she or he is busy. And you stop calling him or calling her. Okay? So that is the time out. Okay? Okie dokie. Let me here use this once again. Okay? Encryption. Okay. For encryption, why we need to use encryption? So encryption is the process for, in another words, changing the information that the information cannot be sold. Let me try to explain you something. Let's suppose that you are sending a message using, for example, let's suppose that you use something that is called encoding. Encoding, this is an O, encoding. And let's suppose that you are using emojis just for encoding your message. Let's suppose that if you send a happy face, that means something from you and from the person that you are sending that emoji. And if you are sending, for example, the evil one, means another thing. So the message that you are sending is something like this, for example. Let's suppose. So only you and the receiver is going to understand what you are trying to say. Okay? That is encryption. Okay? Is the process of encrypt the information. Why? Because let's suppose that here between you that you are sending the message and the person that is going to receive, let's suppose that here in the middle of you, there is another person that intercepts your message. So the information is encrypted. That means that that person is not going to understand what you are talking about. So that is the reason that we use encryption. So the encryption gives you privacy, gives you security, gives you authentication, and prevents misuse. Okay? What that means? The same example that I gave you here. If someone intercepts your message, is not going to be authorized to read the message. Okay? Okie dokie. So we have two kinds of encryption. We have symmetric encryption and asymmetric encryption. So what that means? That you are going to use a key. Let's suppose asymmetric. Ay, sorry. No, let's go first symmetric encryption. Symmetric encryption, that means that you are going to use a key, a private key to encrypt your information. And the person that receives the information, let's suppose this is another key, is going to use the same key to decrypt. That is symmetric encryption. We have another one that is called asymmetric encryption. That means that we are going to use two keys, a public key and a private key. Okay? So, symmetric. This is the example of symmetric, and here we have asymmetric. Okay, the public key, if you want it, you can share it with all the people you want. And you are going to have a private key that is only for you. Why? Because you are going to use the public key to encrypt the message, and only the receiver's private key can decrypt the message. Okay? So let me try to explain you here. Engine. Let's suppose this is you, and let's suppose this is the person that is going to receive your message. Here you have a private key and a public key. So you are going to use your public key to encrypt. And this other person is going to have the same, a private key and a public key. So when you send the message, this person is going to use the private key that that person has to decrypt the message. Okay? And the same in the other way. If this person, this one, wants to send a message to this one, he's going to use the public key to encrypt, and this one is going to use the private key to decrypt. Okay? So this is the way that this asymmetric encryption works. Okay? Example, imagine a mailbox. Anyone can put a letter inside, public key, but only the owner with the private key can open the box and read the letters. Okay? Advantages of asymmetric encryption: it's very secure. You don't need to share your private keys. It's safer to use over the internet. Disadvantages: is lower than symmetric encryption and is more complex for using. Okay? Now here, let me put something like this. Feature: keys used. Symmetric encryption, one shared key. Asymmetric encryption, you have public and private key. Security: less secure. The key must be shared. So you have your private key, you need to share your private key. And asymmetric, more secure. You don't need to share your private key. Speed: symmetric is fast, asymmetric is slower. Use case: symmetric is used for encrypting large data, and asymmetric is secure communication and key exchange. Okay, so guys, I hope this part of data transmission is clear for you. This video was longer than I was expected, so 1 hour and a half. Oh my goodness. But I hope that this video is useful for you. Okay, so see you in a next video. So bye bye.